Okay, let's go. Number 1. The ALH 84001 Mars meteorite. On December 27, 1984, a geologist named Roberta Score, working with the Antarctic Search for Meteorites program, spotted a greenish-gray rock sitting on the blue ice of the Allen Hills in Antarctica, a region where dark meteorites are easy to find against the ice sheet. The rock was catalogued as ALH 84001 and, for nearly a decade, sat largely unstudied. Isotopic analysis eventually established that it was not from Earth. Gas trapped inside matched the specific atmospheric signature measured by the Viking landers on Mars, proving the rock had formed on Mars roughly 4 billion years ago, been blasted into space by an asteroid impact around 17 million years ago, drifted through the solar system, and landed in Antarctica approximately 13,000 years ago. It is, to date, one of only a small number of confirmed Martian meteorites ever recovered on Earth. In August 1996, a team of NASA scientists at Johnson Space Center, led by planetary geologist David McKay, published a paper in the journal Science, laying out multiple independent lines of physical evidence inside the rock that, taken together, they argued were consistent with ancient microbial life. Carbonate globules embedded in the rock's cracks, polycyclic aromatic hydrocarbons, organic compounds that on Earth are strongly associated with the decay of biological material, and, most strikingly, chains of magnetite crystals, a mineral that on Earth is produced in that specific chain-linked, high-purity form by almost nothing except magnetotactic bacteria, microorganisms that manufacture internal magnetic compasses to orient themselves. Electron microscope images also revealed segmented, tube-like structures resembling fossilized microorganisms, though far smaller than any confirmed bacteria on Earth, small enough that some scientists doubted they could be biological at all. On August 7, 1996, President Bill Clinton addressed the finding from the White House lawn, calling it one of the most stunning insights into the universe that science had ever uncovered, and NASA Administrator Daniel Goldin briefed Congress the same week. The scientific backlash arrived almost immediately. Researchers argued the carbonates could have formed abiotically at high temperature, that the organic compounds could reflect Antarctic ice contamination or interstellar chemistry unrelated to life, and that structures this small strained the definition of a cell. The magnetite evidence proved harder to dismiss. NASA researcher Kathy Thomas Kepperda and her colleagues continued analyzing the crystal chains for over a decade, and in a 2009 paper in the Proceedings of the National Academy of Sciences, still defended the magnetite's specific structure as effectively indistinguishable from biologically produced crystals, a claim critics have contested but never definitively disproven, with an accepted abiotic mechanism. No unified retraction was ever issued. NASA did not walk the finding back, so much as let the public conversation move on. The meteorite itself is exceedingly rare material to argue over. Of the tens of thousands of meteorites catalogued from Antarctica's ice fields since the search program began in the 1970s, only a small handful have ever been confirmed as Martian in origin, making ALH 84001 of a limited set of physical Mars samples. Humanity possessed decades before any spacecraft returned so much as a gram of Martian soil. ALH 84001 still sits in a climate-controlled vault at Johnson Space Center, still occasionally pulled out for new analysis using nanoscale imaging instruments that did not exist in 1996, still carrying magnetite chains nobody has fully explained through non-biological means. A rock that fell from Mars, was picked up off Antarctic ice, and once made a sitting president say the word life, remains in a drawer, unresolved, 3 decades later. Not every piece of unexplained physical evidence has been sitting quietly in a vault. Some of it was recorded by the United States Navy, on camera, in real time. Number 2. The USS Nimitz Tic Tac encounter. On November 14, 2004, radar operator Kevin Day, aboard the guided missile cruiser USS Princeton, was tracking a cluster of unidentified radar returns that had been appearing intermittently over the preceding 2 weeks, roughly 100 miles off the coast of San Diego, during a scheduled carrier strike group training exercise. The objects had been descending from above 80,000 feet to hover at around 50 feet above the ocean surface in seconds, a rate of descent no aircraft in the Navy's own inventory could survive. Day directed a flight of FA-18 fighters, led by Commander David Fravor, to investigate. Fravor and his wingman, Lieutenant Commander Jim Slate, arrived to find the ocean surface disturbed in a roughly 50-foot patch of whitewater with no visible cause, and above it, a smooth, white, featureless object roughly 40 feet long, with no wings, no exhaust, and no visible control surfaces, moving erratically. As Fravor's jet descended toward it, the object began mirroring his flight path before abruptly accelerating away. Radar aboard the Princeton picked the same object back up less than a minute later, 60 miles away, a closure speed that would require sustained acceleration far beyond any known aircraft. A second pilot, Lieutenant Commander Chad Underwood, launched shortly afterward and briefly achieved an infrared sensor lock on an object matching the earlier description, capturing roughly 90 seconds of footage before the object accelerated beyond the tracking capability of his targeting pod and the lock dropped. That recording, later declassified, became known publicly as the Nimitz Tic-Tac footage, after the shape the pilots used to describe it. In post-flight debriefs conducted separately, and without the crews conferring beforehand, multiple aviators independently described and sketched an object of nearly identical size, shape, and coloring. The encounter was corroborated independently by radar operators aboard the Princeton, the visual accounts of at least 2 air crews, and the infrared sensor recording, 3 separate data sources agreeing on an object with no conventional explanation. The footage and the radar logs remained inside classified Navy channels for 13 years. In December 2017, the New York Times published the first public account of the incident, alongside the infrared video, revealing the existence of a Pentagon program that had been quietly studying the case and others like it. The Department of Defense confirmed in 2020 that the footage was authentic Navy sensor data and that the object depicted remained officially unidentified, the first time the U.S. government had confirmed on the record that its own instruments had recorded something it could not explain. Fravor, a career Navy fighter pilot with thousands of flight hours and a squadron commander at the time, has stated publicly and consistently since 2017 that the object outperformed anything in the American or any known foreign arsenal. The 2021 preliminary assessment on unidentified aerial phenomena delivered to Congress by the Office of the Director of National Intelligence lists the Nimitz encounter among the incident reports it reviewed, one of the small number involving multiple independent sensor types confirming the same contact. No radar malfunction, sensor glitch, or known aircraft profile has ever accounted for all 3 independent data streams at once. Kevin Day's original radar logs, the 2 pilots' visual accounts, and Underwood's infrared recording remain, collectively, an unresolved contact between a U.S. Navy carrier group and something its own confirmed instruments could not identify, 16 years before anyone outside the Navy was allowed to see it. Day has since stated publicly that in over 20 years of operating naval radar systems, he had never before or since logged a contact behaving the way that one did, ruling out, in his own assessment, routine sensor artifacts or weather phenomena he had encountered thousands of times in his career. Number 3. The HD 164595 signal. On May 15, 2015, the Raton 600 radio telescope near Zelenchukskaya in southern Russia, one of the largest and most sensitive dish arrays in the world, recorded a strong, brief transient signal at a frequency of roughly 11 GHz coming from the direction of HD 164595, a sun-like star located about 94 light-years from Earth. The star was already known to host at least one confirmed planet, a Neptune-sized world orbiting close to its sun, discovered through radial velocity measurements years earlier, and possibly additional undetected planets farther out, according to the same survey data. The signal itself was not published or widely discussed until the following year, when word of it began circulating informally among astronomers and SETI researchers, most visibly through Paul Gilster's respected Centauri Dreams blog, before any formal peer-reviewed paper had been released, a delay that itself became part of the controversy once the story broke publicly in August 2016. Russian astronomer Alexander Panov and colleagues at the Raton 600 facility ran the numbers. If the signal genuinely originated at HD 164595 and was broadcast in every direction rather than aimed narrowly at Earth, the transmitting power required would have to exceed anything human civilization has ever generated by several orders of magnitude. An omnidirectional beacon on a scale associated in some SETI frameworks with a civilization classified far above our own on the Kardashev scale. A system astronomers use to rank hypothetical civilizations by the sheer amount of energy they can harness. A narrowly aimed, deliberate transmission would require far less power, but would also mean someone had pointed it directly at our solar system, deliberately or not. For several weeks, the signal sat in an uncomfortable position, real, recorded, sourced to a specific and previously catalogued star system, and not yet explained. The eventual, more widely accepted account is that the signal was terrestrial interference, most likely from a military or classified satellite passing through Ratan 600's field of view at the moment of detection, a phenomenon that has caused false alarms at radio observatories before and since, including at other facilities scanning similar frequency bands. That explanation was never conclusively proven. No specific satellite was ever named publicly as the confirmed source. No follow-up observation of HD 164595 itself has ever detected the signal again, despite repeated attempts by SETI programs, including Breakthrough Listen, to listen for a repeat in the years since. What is left on the record is a single recorded event, an 11 GHz burst, logged by a functioning observatory, pointed at a star known to host a planet, that briefly triggered exactly the kind of informal internal alert protocol SETI researchers have always said would precede a confirmed detection, before being downgraded to probable interference on the strength of precedent rather than direct proof. The star is still there. The planet is still there. Whatever passed in front of the dish that night in 2015 was never definitively identified, only judged, after the fact, more likely to have come from one of our own machines than from anyone else's. The SETI Institute's own Allen Telescope Array in California conducted a dedicated follow-up campaign specifically targeting HD 164595 in the weeks after the story broke, an unusual allocation of scarce observing time for a signal most researchers already suspected was mundane, underscoring how seriously the possibility was treated even as it was being quietly downgraded. Number 4. BLC-1. In April and May of 2019, the Parkes Observatory in New South Wales, Australia, one of the primary instruments used by the Breakthrough Listen initiative, spent 26 hours pointed at Proxima Centauri, the closest star to our Sun and home to at least one confirmed rocky exoplanet, Proxima b, orbiting inside its star's habitable zone. Breakthrough Listen is the largest scientific search for extraterrestrial technosignatures ever funded, backed by more than $100 million from investor Yuri Milner, launched publicly in 2015, with support from physicist Stephen Hawking, and involving researchers from the University of California, Berkeley, and institutions worldwide, scanning millions of star systems across a broad range of radio frequencies. Buried inside the terabytes of data collected during that observing run was a narrowband signal at 982.02 MHz, a frequency with no known natural astrophysical source, and no assigned terrestrial use at that exact band. The signal appeared only when the telescope was pointed at Proxima Centauri and disappeared when the telescope was pointed away, the single most basic test used to separate a genuine astronomical signal from local interference, a test most false alarms fail immediately. It also showed a slow drift in frequency consistent with the kind of Doppler shift produced by a transmitter on a rotating or orbiting body, exactly the signature Breakthrough Listen's detection algorithms are built to flag as a technosignature candidate, and a pattern that automated interference rejection filters are specifically designed to catch and discard. The observation used a standard on-off cadence, pointing at Proxima Centauri, then away, then back again several times over the 26 hours, specifically so any signal tied to the star itself would appear only during the on-target scans, which is exactly what BLC-1 did across every pass. The signal, later designated BLC-1 for Breakthrough Listen Candidate 1, sat inside the collaboration's internal review process for over a year before any public disclosure, a delay driven by the scale of the claim and the need to rule out every conventional explanation before saying anything publicly, a level of caution the team has said was deliberate, given how quickly past unexplained signals in the field had been overhyped before the data was fully vetted. It survived that review long enough to make it into a peer-reviewed analysis. In October 2021, the journal Nature Astronomy published a paper led by astronomer Sophia Sheikh, then at Berkeley SETI Research Center, walking through the full investigation across dozens of co-authors. The paper's conclusion was that BLC-1 was most likely radio frequency interference generated by human electronics on Earth, based on subtle drift rate artifacts consistent with terrestrial equipment rather than a moving astronomical transmitter. The paper is also explicit that the exact source device or facility responsible was never identified, despite an extensive search through logs of known local transmitters operating near the observatory. No specific piece of terrestrial hardware was ever named as the culprit. What survives on the record is a narrowband radio signal, sourced to the direction of the nearest star system to our own, that passed the automated filters specifically engineered to reject false positives, underwent more than a year of expert scrutiny by one of the best-funded SETI programs ever assembled, and was ultimately downgraded rather than definitively explained. Number 5. FRB 180916. Fast radio bursts are among the most energetic events astronomers have ever detected. Millisecond-long flashes of radio energy that, in that fraction of a second, can release as much energy as the sun radiates over days, a scale of output that still has no fully agreed-upon single explanation across the thousands of bursts now catalogued. Most fast radio bursts appear once and never repeat, making them nearly impossible to trace back to a source or a host galaxy. In 2018, the Canadian Hydrogen Intensity Mapping Experiment, known as CHIME, a radio telescope in British Columbia, built primarily to study the early universe through hydrogen emission, detected a fast radio burst that did something almost none of its predecessors had done. It came back, repeatedly. Astronomers designated it FRB 180916, later localized with high precision to a star-forming region within a spiral galaxy roughly 500 million light-years from Earth, close enough by cosmological standards to study its host environment in real detail using follow-up optical telescopes. Then, in 2020, a team analyzing the accumulated detections published a paper in the journal Nature reporting something that turned an already strange object into a genuinely disquieting one. The bursts were not random. They followed a period of activity lasting approximately 4 days, during which bursts could occur in clusters, followed by roughly 12 days of complete silence, repeating in a cycle measured at 16.35 days, with a precision tight enough that astronomers could predict, in advance, the windows during which the source would be active and the windows during which it would go quiet, and subsequent observing campaigns confirmed the prediction held. Nature does not typically build clocks. Stars burn on internal processes governed by nuclear physics, not external scheduling. Pulsars rotate with extraordinary regularity, but a rotating neutron star does not, on its own, explain why an object would burst for exactly 4 days, and then fall completely silent for exactly 12, over and over, for years without drifting off schedule. The leading natural explanation proposes a magnetar, an extraordinarily magnetized neutron star, locked in a binary orbit with a companion star or compact object, with the burst activity somehow gated by the orbital geometry of the pair, as the magnetar's environment periodically becomes favorable for burst production. That model is plausible. It is also incomplete. No published simulation has yet reproduced the sharpness and precision of the observed 16.35-day cycle from first principles and several other repeating fast radio bursts discovered since by CHIME and other facilities, each with its own distinct periodicity ranging from days to months, have only deepened the puzzle of why the universe would repeatedly produce objects that behave like scheduled beacons rather than the chaotic, unpredictable transients astrophysics generally expects from extreme stellar remnants. In April 2020, a burst with fast radio burst-like properties was traced for the first time to a known magnetar inside our own galaxy, SGR 1935 plus 2154, lending real support to the magnetar hypothesis in general. That source, notably, has never shown anything resembling FRB 180916's disciplined 16.35-day cadence, leaving the periodicity itself as unexplained today as it was in 2020. Whatever is inside that galaxy 500 million light-years away, it has been turning on and off on the same 16-day interval since before CHIME ever pointed a dish in its direction, and it is still running. Number 6. Phosphine in the clouds of Venus. Venus is, by surface conditions, the least hospitable planet in the solar system, a world with a surface temperature of roughly 870 degrees Fahrenheit, hot enough to melt lead, and an atmosphere 90 times the pressure of Earth's, laced with clouds of concentrated sulfuric acid capable of dissolving most spacecraft components on contact. It is not where planetary scientists expected to find a possible biosignature. In September 2020, astronomer Jane Greaves of Cardiff University, leading a team using the James Clerk Maxwell Telescope in Hawaii, and the Atacama Large Millimeter Array in Chile, published a paper in the journal Nature Astronomy reporting the detection of phosphine gas in Venus's upper cloud layer at an estimated concentration of roughly 20 parts per billion. Phosphine is a molecule of one phosphorus atom bonded to 3 hydrogen atoms, and on Earth it has no significant abiotic production pathway at that kind of concentration outside of industrial manufacturing or specific anaerobic swamp and marsh environments. It is generated almost exclusively by anaerobic microbial life, or by industrial processes humanity has never deployed on Venus. Finding its spectral signature on a planet with no industry immediately raised the second possibility. Venus's surface is lethal, but the cloud layer roughly 30 miles up, where the phosphine signature was detected, sits at a temperature and pressure close to conditions on Earth's surface, a narrow, ferociously acidic band that some astrobiologists have long speculated, even before 2020, could theoretically support microbial life adapted to it, floating rather than settling to the ground. The announcement triggered immediate scrutiny from the broader planetary science community. Within months, several independent teams challenged the data processing methods used to extract the signal, arguing that instrumental artifacts and calibration choices in the original spectral analysis could have produced a false detection. Greaves and her collaborators re-examined the raw data, acknowledged some of the original calibration issues publicly, and reprocessed the observations using a revised method. The revised analysis still showed a phosphine signature at a lower but still statistically significant concentration than first reported. Subsequent independent observations using different spectral lines associated with phosphine have, in some cases, reaffirmed detection and, in others, failed to reproduce it, leaving the scientific community genuinely split rather than settled in either direction years later. No abiotic chemical pathway proposed since 2020, including volcanic outgassing, lightning, and photochemical reactions in the Venusian atmosphere, has fully accounted for the measured concentration under Venus's specific cloud conditions. The dispute remains open enough that multiple space agencies have since committed hardware to resolving it directly, rather than continuing to argue over remote spectroscopy. NASA's Da Vinci and Veritas missions, and a privately funded Rocket Lab probe, are all being developed partly to sample Venus's atmosphere directly, rather than continue arguing over telescope data from 24 million miles away. On Earth, phosphine's overwhelming association with biology is exactly why it is used industrially as a regulated fumigant, manufactured deliberately because nature so rarely produces it in usable quantity outside of living systems. Until one of those probes flies through the clouds and measures the gas directly, the closest planet to Earth carries an unresolved chemical signature that, on this world, has only ever meant one thing. Number 7. Dimethyl sulfide on K218b. K218b is an exoplanet roughly 124 light-years from Earth, about 8.5 times the mass of Earth, orbiting inside the habitable zone of a small red dwarf star. Since its atmosphere was first characterized, planetary scientists led by Niku Madhusudan at the University of Cambridge have classified it as a candidate Hycean world, a term coined for a planet hypothesized to carry a thick hydrogen-rich atmosphere sitting above a vast planet-covering liquid ocean, a category of world that does not exist anywhere in our own solar system and was proposed specifically to explain planets of K218b's size and density. In September 2023, Madhusudan's team published results from the James Webb Space Telescope's observations of K218b's atmosphere, reporting the possible detection of 2 related molecules, dimethyl sulfide and dimethyl disulfide, alongside methane and carbon dioxide, already confirmed in earlier observing runs. On Earth, dimethyl sulfide is produced almost exclusively by marine phytoplankton, single-celled ocean organisms that release the compound as part of their metabolism, and it has no confirmed significant abiotic source at comparable concentrations anywhere in the solar system. Finding its spectral signature in the atmosphere of a distant candidate ocean world was, by any measure, the closest thing to a biosignature detection ever pulled from an exoplanet's atmosphere. The claim came with an immediate, explicit caveat from the team itself. The statistical confidence of the detection sat at roughly 3 standard deviations, a level that in scientific practice indicates a promising signal worth investigating further, but falls well short of the 5 sigma threshold physicists require before calling something a confirmed discovery, the same bar used to certify the Higgs boson in 2012 after decades of searching. Other researchers moved quickly to challenge more than the confidence level. A team including planetary scientist Christopher Glein at the Southwest Research Institute disputed both the specific molecular identification, arguing the spectral features could be explained by other, more mundane compounds present in a hydrogen-rich atmosphere, and the underlying assumption that K218b has a true ocean at all, rather than a deep, high-pressure layer, more consistent with a scaled-up ice giant than a habitable water world. The dispute remains unresolved, because the observation itself has not yet been repeated with sufficient precision to settle it either way. Additional James Webb observing time has since been allocated specifically to re-examine K218b's atmosphere at higher resolution, an acknowledgement from the scientific community that the question is significant enough to justify one of the most oversubscribed telescopes in history, pointing back at the same faint red dwarf system rather than moving on to a new target. The concentrations initially reported were also strikingly high, tens of parts per million in some estimates, thousands of times greater than dimethyl sulfide levels found over Earth's own oceans, a figure Madhusudan's team has said would need an extraordinarily productive biosphere to sustain if the biological explanation holds. Until that data returns, humanity has one honest entry in its logbook, a molecule that everywhere we have ever found it in usable concentration has meant life, detected in the air of a world we cannot yet say for certain has an ocean, orbiting a star we cannot visit, at a confidence level that leaves the door open rather than closed. Number 8. The USS Omaha Sphere Encounter. Every known human vehicle is built for one medium or the other. Aircraft are engineered to minimize drag through thin air at altitude, with hulls that would be crushed or torn apart by sustained high-speed contact with water. Submarines are engineered to withstand the pressure of dense water, with hulls too heavy and too poorly shaped to fly. No existing human technology performs at a high level in both environments at once. On the night of July 15, 2019, the guided missile destroyer USS Omaha was operating roughly 100 miles off the coast of San Diego as part of a multi-ship training exercise when its crew detected a small spherical object on radar, closing on the ship at high speed before coming to a stationary hover directly above it. Sailors on deck visually confirmed the object using night vision equipment, and the ship's sensor operators tracked it simultaneously on radar and infrared camera, 3 independent systems recording the same contact at once. According to the incident report, later obtained by journalist Tim McMillan and published by the outlet The Debrief in 2021, through a Freedom of Information Act request, the object then descended toward the ocean surface and disappeared beneath it without any recorded splash or reduction in speed, a transition that should have produced a visible impact on both the infrared and visual recordings. Sonobuoys were dropped in the area afterward specifically to search for an underwater contact. None was found. Audio captured from the ship's own communications during the incident recorded crew members reacting in real time to the object's descent and disappearance beneath the surface, a live, contemporaneous record, rather than a recollection assembled after the fact. The Omaha encounter was not an isolated event. Naval records and subsequent reporting confirmed that similar small spherical or cylindrical objects, sometimes appearing in clusters of 5 or more, sometimes displaying no visible running lights and sometimes displaying blinking ones, were tracked near multiple vessels in the same strike group on separate nights that same July, incidents naval aviators and officials have since referred to informally as the 2019 swarm events, prompting internal Navy briefings and eventually a review by the Pentagon's newly formed Task Force on Unidentified Aerial Phenomena, which treated the encounters as among its founding case files. Christopher Mellon, a former Deputy Assistant Secretary of Defense for Intelligence, who reviewed elements of the case, has publicly used the term transmedium to describe objects that cross between air and water without measurable friction or deceleration, a term serious enough that the Office of the Director of National Intelligence adopted it as one of 5 official categories in its 2021 report to Congress on unidentified aerial phenomena. No foreign military has been formally identified as the source of the Omaha object, and no engineering explanation has been offered for a small craft that performs equally well submerged and airborne, tracked simultaneously by radar, infrared, and the human eye, over a U.S. Navy destroyer during a routine exercise, on a night when nothing about the weather, sea state, or onboard equipment was flagged as unusual before or after the encounter. The sonar run that found nothing beneath the waves that night was not the first time an American instrument recorded an echo it could not explain, and then simply came up empty. Number 9. Duncan Lunan's signal. Between 1927 and 1929, radio experimenters across Europe, most notably Jørgen Hals in Norway, working with physicist Carl Stormer, recorded a phenomenon that should not have been possible with the equipment of the era. Transmitted radio pulses returned as echoes delayed by several seconds, far too long to be explained by a bounce off the ionosphere, and inconsistent with a moon bounce as well, since a round trip to the moon and back covers roughly 478,000 miles and takes about 2.5 seconds at most, a fixed number that does not match the variable, multi-second delays the operators were logging. The recordings were archived and largely forgotten outside specialist radio circles for 4 decades. In the early 1970s, Scottish engineer Duncan Lunan obtained a specific surviving dataset of these delay time measurements and began systematically plotting each echo's delay time against the order in which it was received, treating the sequence the way a cryptographer treats a suspected cipher rather than noise. In a paper presented to the British Interplanetary Society in 1973, Lunan reported that when the delay times were plotted as coordinates on a star chart, they traced a recognizable pattern resembling the constellation Bootes, with one star, Epsilon Bootis, offset from its true position in a way Lunan calculated would match its actual location roughly 12,600 years earlier. Lunan grounded his interpretation in a concept the Stanford radio astronomer Ronald Bracewell had proposed on entirely independent theoretical grounds in a 1960 paper in the journal Nature, arguing that an advanced civilization wishing to make contact economically might dispatch small automated probes to nearby star systems, probes programmed to detect incoming radio transmissions and retransmit them back with an embedded delay and payload, rather than broadcasting continuously across the galaxy at enormous cost. Applying that framework directly to the archived delay data, Lunan's proposed interpretation was specific and extraordinary. An unmanned Bracewell-type probe, parked in a stable position near the moon, replaying a recorded star map to any civilization that developed radio technology sensitive enough to notice the echoes. The scientific response was swift and largely critical. Several radio researchers, including some who worked with the original data, argued Lunan had been selective about which recorded delay times he used and which he set aside to make the pattern fit, and follow-up attempts by other researchers to reproduce a coherent star map from the same archived recordings did not converge on Lunan's specific result. Lunan himself later acknowledged data selection problems with his original analysis, while maintaining that the core echoes themselves were not in dispute. That distinction is the part of the case that never went away. Lunan continued defending the validity of the raw delay time measurements themselves for the rest of his life, distinguishing between the data he considered solid and the specific decoded interpretation he acknowledged was compromised by his own selective handling of it. The rejection of Lunan's star map interpretation is not the same as an explanation of the underlying data. No conventional mechanism, ionospheric, atmospheric, or instrumental, has ever fully reproduced the specific range and variability of delay times recorded in the original 1927 to 1929 logs that Lunan was working from in the first place. The echoes are still sitting in the archival record, undisputed as measurements, entirely disputed as messages, exactly as they were left by men listening to their own signals come back too late, decades before anyone thought to ask whether the delay itself might mean something. Number 10. Project Hephaestus. If an advanced civilization built a Dyson swarm, a shell or ring of solar collectors surrounding its star to capture nearly all of its energy output, the swarm would not glow visibly the way a star does. It would absorb starlight to power itself, and re-radiate that captured energy as heat, at infrared wavelengths, invisible to the eye, but detectable to the right instrument as a star that puts out far more infrared light than its size and temperature should produce. In 2024, a team of astronomers at Uppsala University in Sweden, led by Erik Zachrisson, published the results of the most systematic search for exactly this signature ever conducted, under the name Project Hephaestus. Rather than waiting for a citizen scientist to spot one anomalous light curve by chance, the way earlier searches for megastructure candidates had worked, Zachrisson's team cross-referenced 3 major astronomical catalogs: the European Space Agency's Gaia survey, the 2-micron All-Sky survey, and NASA's Wide Field Infrared Survey Explorer, covering roughly 5 million star systems, searching computationally for any star showing an infrared excess inconsistent with known stellar physics. The team applied deliberately conservative filters, first eliminating young stars with natural debris disks, background galaxies misidentified as point sources, and known variable stars, categories that account for the overwhelming majority of infrared anomalies in any large survey and that had produced false leads in earlier, smaller-scale searches. After that filtering, the search narrowed from millions of candidates down to 7 M-dwarf stars, whose infrared excess could not be explained by any of the conventional astrophysical categories the team tested against. Zachrison and his collaborators have been explicit and careful in how they describe the result. 7 candidates out of 5 million is not a discovery of alien engineering, and the team has continued follow-up observations specifically designed to rule out subtler natural explanations, including undetected background contamination and rare forms of stellar activity not yet fully catalogued in existing surveys. The search itself is planned in phases, with this first pass covering roughly 5 million systems and later phases intended to extend the survey to tens of millions more as additional catalog data becomes available. But as of this recording, those 7 stars remain on the list, with real coordinates on file and further observing time already requested to examine them individually. Their excess infrared emission has not been explained, and Project Hephaestus was built specifically so that the search for artificial megastructures would no longer depend on a citizen scientist happening to notice one unusual light curve by chance. It is now a standing, systematic, ongoing survey pointed at real stars, looking for exactly the kind of signature this entire list keeps circling back to. A Martian meteorite with magnetite chains nobody has explained away without invoking life. 3 independent U.S. Navy sensor systems recording the same object outmaneuvering a fighter jet over the Pacific. A radio burst from a nearby star that passed every filter built to catch a fake. A cosmic beacon that turns on and off every 16 days like clockwork. A gas tied everywhere else in nature to living cells found in the clouds of the planet next door and in the atmosphere of a world 124 light-years away. A Navy destroyer tracking a sphere that flew, then vanished beneath the ocean without a splash. A radio echo recorded a century ago that still returns seconds late for reasons no one has ever pinned down. And now, 7 stars quietly still on a list, radiating more heat than they should. None of it is proof, but all of it is measured, recorded, and, as of today, unexplained. If you want more of these, subscribe and turn on notifications so you don't miss the next one. Leave a like, drop a comment, and let us know where in the world you're watching from.